There we go. So welcome everybody, and as I said, go ahead and put your town in the chat if you'd like. This is the regular evening program of Los Angeles Audubon Society for March 2023. My name is Travis Longcore. I'm president of LA Audubon, and want to welcome everybody on our behalf. Just two quick notes. If you would like to get on our mailing list for upcoming programs, our newsletter, for the Rare Bird Alert, which comes out every week, go ahead to our website, laaudubon.org, and down at the bottom there's a link to subscribe, and that'll take you to a little dialogue, and you can pick the topics that you're interested in being added to the list for. So I see we've got Santa Monica, West LA, Arcadia, Playa del Rey, Cindy, who works with us in the Biona Education Program. Nice to see you. So that's thing number one. Thing number two is we endeavor to offer all of our programs to the public for free, but actually doing so is not free. And so we welcome anybody who would like to support the work of LA Audubon to become a member. And if you go to our website in the upper right, there's a button on the page that says Join Renew. And you can click through there, and for the low cost of $25 a year, you can be a member of LA Audubon and be able to support things like bird walks and beginning bird walks and bilingual bird walks and open wetlands at the Biona Wetlands, which happens twice every month, for Saturday and second Sunday. And your one opportunity to go out there and get on the wetlands themselves and see some birds. So, and meet the great volunteers and docents and staff of our partner, Nature Nexus Institute, there at Biona. So sign up for the mailing list and become a member should you want to do that, so that we can keep all these events going and free to the public as your entree into birds and to let us do our conservation work as well. So tonight, following on our theme from last month, which was all about lease terns, so shorebirds, we're going to stick with the shorebird theme, and are welcoming Professor Nathan Senner from UMass Amherst, where I do have a few credits. As a matter of fact, I took a winter session at UMass Amherst one very cold January. Took a winter session class there. Love it, great part of the state. But you're going to talk about Pacific Flyway migration, which we really appreciate, and your research starting from the Hudsonian Godwit and expanding from there. So I'll let you tell a bit about your background and story. I want to welcome you and thank you for taking the time late your time to talk to us out here on the West Coast, and welcome you to LA Audubon. So go ahead and take it away.
Well, thank you so much. Let's make sure I can successfully share my screen here. You all seeing that? Excellent. Well, yes, thank you so very much for the invitation. It's a real pleasure to be able to talk with all of you this evening and to talk with you about shorebirds, which really are my true love. And the theme of the evening is both shorebird migration, but also shorebird conservation in this new era that we're I think just now starting to everyone call it the Anthropocene. And that of course presents some challenges, but it also presents some amazing opportunities. But before I get into that, I wanted to give you just a little flavor about, yes, my personal background. So I am very privileged in fact that my parents were both nature lovers and my father a professional biologist. And so starting at a very early age, as you can see here, I was indoctrinated into the world of birds and bird watching. Spent my early years at Hawk Mountain Sanctuary, which is a famous hawk migration site in Pennsylvania. Beautiful views from here on the North Lookout. But the key part of this photo actually is really that I hated birds at this age. And you can tell this because in that very cute photo of me looking through the binoculars, I'm looking through them backwards. That was my form of rebellion. and way to stick it to the man, not take up bird watching. But a funny thing happened about the age of 8. My family moved to Alaska in the wake of the Exxon Valdez oil spill, and about that time, my dad took me along on a work trip to the Copper River Delta, which, if any of you have heard about the Copper River Delta, is the place to see shorebirds during spring migration, with literally more than 1 million western sandpipers and dunlin on view and these incredible vistas in the background. And what really got me going, though, was a scene like this. A merlin came down from behind me in a stand of trees and just put up this massive flock of western sandpipers, and they just wheeled around in one of these murmurations, and all of these individuals seeming to act like one, and my 8-year-old mind was sufficiently blown. And from that point on, I was really hooked on birds, and especially shorebirds. And having that privileged, lucky childhood that I did, what I was able to do was to parlay that passion into working for a lot of biologists all over the state of Alaska, largely with shorebirds. This is a bristle-thighed curlew that I'm holding right here. And, truth be told, at this point, I was just so excited to A, not be hanging out with my parents in the summer, and B, being able to see birds that even from home confines of Anchorage, I wasn't normally able to lay eyes on. But along towards the end of high school, one of the people that I was working for, Bob Gill here, published a paper that blew my mind another time, and that was into the migration physiology of these shorebirds. This one happened to be about bar-tailed godwits, and it had this catchy title, Guts Don't Fly. And what that guts don't fly was referring to was all of the physiological changes that shorebirds undergo as they're about to take their epic flights. So we have a graph here that on the y-axis shows you the ratio of the masses of these organs between their migratory sort of preparation phase and their sedentary phase. So say during the non-breeding season on the wintering grounds. And if you look there on the very left, you see that, say, the mass of the leg muscles of a bar-tailed godwit aren't that different between that pre-migratory phase and that sedentary phase. But then you look at fat. Fat, they have more than doubled their sort of normal carrying capacity. But even more remarkable is those guts that don't fly. They've shrunk their gizzard, their liver, their kidneys to basically about half the size that they would normally be, all to economize the ratio of the various organs that they're going to need while they're making their epic flights. And this was what set me on the path to really being a scientist and not just a happy kid going around twitching birds in Alaska. And so when I graduated from college, I set my mind to solve a migration mystery of my own, and that was the mystery of where Hudsonian Godwits migrated after they left Alaska. So I could see Hudsonian Godwits almost out my back door as a kid, but we didn't really know anything about what they did in order to make it all the way to their known wintering grounds at the very southern tip of South America. And so I was lucky enough to be awarded what's called a Thomas J. Watson Fellowship, which is available to folks graduating from small liberal arts schools like I was. And I used that fellowship to trek all over South America. And I know that these arrows don't show up especially well, but all of those are sites where I was able to either hitchhike or take a bus to go and try and figure out what godwits were doing. And it was frankly probably a year that I will never top in my entire life. But at some level, I must admit, it was a failure because I didn't see a single darn godwit anywhere where someone hadn't seen one before. I did nothing to solve this mystery. But another sort of magical coincidence basically greeted me when I returned back home to the US, and that was the advent of a technology that you're seeing right here. If you ignore the dirty fingernails and cut up thumbs, and this is a satellite transmitter that on about 2005, 2006, all of a sudden became small enough, put on the back of a bird like a Hudsonian Godwit. And the very first bird that really started to show off the stuff of these satellite transmitters was another species of godwit, that bar-tailed godwit whose guts don't fly. And the satellite transmitters that folks put on them unveiled something that really very few people could ever have imagined before actually making use of this technology. And that is that it took off from the coast of Alaska that you can see in the sort of upper right-hand corner of that map, and it flew nonstop to New Zealand over the length of the Pacific Ocean. In this case, 9 days, 11,700 kilometers. If you're trying to do math into miles, I think that's somewhere around 6,800 miles. It got to New Zealand, spent the winter there, and then it took back off and made nearly exactly the same kind of flight to the Yellow Sea in China, spent a few weeks, and then, a measly 7,200 kilometers more nonstop back to the breeding grounds in Alaska. So that then, I was a scientist, but this set me on my career path. I knew that what I wanted to do was to be able to use these kinds of technology to capture the majesty and mystery of the flights of these birds. And hopefully then to be able to be on the ground with them when they were actually on the ground, and to learn things about them that we could use to aid their conservation. And so that's exactly what my research program is focused on. We use tracking devices. We tend to follow migratory shorebirds, and then we couple them with things that we can measure using other kinds of maybe sort of more quotidian technologies, like we measure resource abundance, insects, using pitfall traps in the tundra. We put light flags on them so that we can follow these individual birds when they're on the ground and how they're able to reproduce. We make use of remote sensing technologies that allow us to use satellite imagery to place their environmental context in a much broader scale and sense. And then we also partner with community scientists to try to monitor the population trends of these species. All, as I mentioned, in the service of conservation. And so what I want to do tonight is to sort of take you on a journey with Hudsonian Godwits, which remain the focal species for my lab's research agenda, and tell you how we've sort of built up a team that is able to follow these birds throughout their lives. And so what started as me sort of lonely and hitchhiking across Patagonia and South America has now sort of been built up into this really incredible set of network of team members that span the Western Hemisphere and allow us to be observing individual birds basically everywhere that they might choose to stop. So what does a godwit's life look like? Well, let's start at the cute stage. This is a very newly hatched Hudsonian Godwit chick. They are precocial chicks. Just like chickens, they're able to leave the nest within an hour or two. They can cover a kilometer within their first day of life. And that comes with some benefits, of course, but it also comes with some challenges. And one of those challenges is finding enough food to eat, and especially doing so in the Arctic and subarctic where Hudsonian Godwits breed. So this graph right here shows you the summer season for a godwit and how much insect biomass is available on the landscape for them to actually make use of. So if you're a godwit chick, what you really want to have happen is for you to be hatched during that blue box that you can see there. That's the peak period of insect abundance, and that box is 28 days wide, which is exactly the amount of time that it takes a godwit to transition from having hatched, being fully independent and able to leave to find food resources of its own, say out on some intertidal mudflats. So you really want to have grown up during that period, because you can see here, if you follow that blue line, if you're trying to find insects on the tundra outside of that blue box, outside of that peak period, you're probably SOL. Really short window during which godwits are able to actually successfully transition from chick to fledgling. And so, not surprisingly then, if we look at the survival rate on a daily basis of godwit chicks in relation to the amount of insects that are available on the landscape, we see a really, really striking pattern where when there are few insects on the landscape, you're very, very unlikely to even make it through a day. So there's just incredibly strong pressure to be able to find food and grow quickly. And within 28 days, this is more or less what a godwit chick looks like. It's able to fly. Bill may not be quite as long as that of an adult. Its legs maybe not quite as long, but it's looking like what we would generally recognize as a shorebird. At the same time, though, as the title says, mom and dad are gone by this point. They've left, they've started their migration back south, and so these young godwits are on their own. So they're hopefully able to leave the bog, the tundra, and then they've got to move out to intertidal mudflats where they have to get fat, and they have to get fat fast. Because even if those intertidal mudflats maybe have more resources than the tundra did after that sort of short window I showed you, it's not too long before fall really sets in. And they've got a long migration ahead of them, and they need to prepare for it, just like those bar-tailed godwits did that I showed you earlier. They've got to get really fat. And that's because from, say, south central Alaska, where this bird was born and raised, they've got to make it all the way down to the southern tip of South America. And they have to do so in a series of quite remarkable long nonstop flights. So from our long-term study site at Beluga, Alaska, those chicks first hop 3,000 kilometers to, say, central Saskatchewan in Canada. They spend a few weeks there. Then they hop onto the Amazon basin, then to Argentina, and finally onto Chiloé. And so, mind you, right, all of this is within the first couple of months of their life, and much of it is done without their parents around to be there to guide them. And this migration, by and large, we think is done alone by the juveniles without any adults around. So if you are lucky enough to have successfully run this gauntlet, where you wind up is this idyllic place. This is Chiloé Island in southern Chile, and it is sort of mecca for at least godwits that are breeding in Alaska. There are intertidal bays like these where thousands upon thousands of godwits will congregate. All right, so life sounds pretty hard for godwits, but does it stay that way once they successfully become adults? It depends on how you look at it. I showed you this part of their annual cycle, but what comes next might seem even harder, and that is they're making flights that are only second to those bar-tailed godwits in their duration and distance covered. So they travel from Chiloé Island to the rainwater basin of Nebraska, or potentially even further north into the Dakotas before they make their first stop. So we've had some birds go about 11,200 kilometers in 7 days. And then they stop there for about 2 weeks before making their return flight back up to Beluga. But the remarkable thing about this is that you might think, okay, well, maybe there are just some years when an adult godwit says, you know what, I really don't want to go back to Alaska this year. But that's not actually the case. So on average, an adult godwit can live for about 10 years. And the average adult godwit during those 10 years is going to fly more than 140,000 miles just during migration. This doesn't even take into account their daily forays and chasing each other around the tundra. But they never skip a breeding season. They do that migration over and over and over again without missing a beat. And they're also even able to make up for lost time. So say a godwit might leave Beluga a couple days later than it wants to in a particular year. What we found is those sort of delays might build up as they head south, where they might wind up back on Chiloé sort of 10 days later than on average. But Chiloé, at least historically, was such a good place that they were able to right themselves and then the following spring take off back on time and stay on time all the way to Alaska. So they are really able to make up for that lost time and flexibly respond to the conditions that they're encountering along their migratory route. And we've also found, surprisingly, that despite the extremeness of their migration, godwits are surviving at really high rates. So on average, about 75% of adult godwits survive from year to year. And what you're seeing here, though, is the fact that if you look sort of at the average proportion of adults that are surviving across all shorebird species and the maximum distance that they fly, there on the x-axis, you don't see any relationship between migration distance and the proportion of birds surviving. So migration really seems to be built in to the sort of the fabric of the lives of these shorebirds, and so it's not in and of itself presenting the challenge that we might think that it would, given our sort of ground-based lives. So from this perspective then, maybe adult godwits actually have an easy life. And that would be a really nice way to end this talk, but that's also not the whole story. So you all are probably aware that there are recent estimates suggesting that as a whole in North America, we've lost about 3 billion breeding birds over the past 4 or 5 decades. Well, shorebirds are unfortunately leading the charge downwards, and especially long-distance migratory shorebirds. So on average, if you look across the 19 species of long-distance migratory shorebirds, their populations have declined by over 50%. And a recent paper suggested that at least the Atlantic coast population of godwits has declined by 98% during the same time period. Now, to be totally truthful, I think that's probably a bit of an overestimate, but no matter what it is, it's not a sign of good things for godwits or any of the other shorebirds. So what's then causing this issue? Well, the answer is myriad simultaneous changes. Basically, everywhere that godwits are making landfall, something is happening to them that's changing their environment from how they may have evolved to use it. So we know that on the breeding grounds, there has been rapid warming over the past couple decades, and it's happening in the Arctic at rates that are far higher than basically anywhere else on Earth. This shows you mean April and May temperatures, which is when godwits are arriving and breeding in Beluga, Alaska. And the scale of this is such that those actually don't look like dramatic slopes of temperature rise, but they're about 3 degrees C over that period. We also know, say, on the southbound migration, that the Amazon is being deforested at an incredible rate with unknown consequences for the kinds of habitats the godwits and other shorebirds are using when they stop over there. That sort of glorious place, Chiloé Island, that I was telling you about, is increasingly under pressure from aquacultural industries. So this photo right here is an intertidal bay on Chiloé, and there are no less than 3 different kinds of aquaculture practices that are taking place just in that photo. And this leads to a lot of disturbance in these intertidal areas that is potentially influencing godwits. And then as they move back northward into North America and stop in the rainwater basin and in the central Dakotas, we see that even after already a century of agricultural conversion, more and more land is being converted to agriculture every year, with, again, consequences for the availability of wetlands like you see in the top of this photo. So how is it that all of these changes are actually affecting the lives of shorebirds? Well, let's start on Chiloé. So I told you that disturbance is becoming an issue in all of those bays where the godwits spend their time. And what we see is that that influences the body condition of godwits while they're actually in Chiloé. So this graph right here on that y-axis is an index of body condition, and what we mean by that is how much fat they're carrying at any one time. More positive numbers mean better body condition. And on the x-axis is an index of disturbance, or what we're calling patch quality. So you can see that individuals in higher quality patches are in much better body condition. That's not necessarily surprising, but it's important to actually show. In turn then, if we hop up to Beluga and look at who is actually successfully able to return to Beluga from the non-breeding grounds on Chiloé, we see that an individual's condition on Chiloé strongly predicts the likelihood that they're actually going to successfully survive northward migration and make it back to Beluga. So those that did not return there on the left-hand side, you can see had much lower body condition on Chiloé than did the ones that actually successfully returned. What's mitigating that sort of poor survival? Well, it's the fact that godwits, while they're stopped over in the central U.S., are predominantly using agricultural wetlands. So this is a graph showing the proportion of the different habitats that make up the stopover sites that godwits are making use of. And you can see that more than 50% of the sites that they're using are row crop agriculture, with another large proportion then being made up of managed grasslands or ranch-style pastures. So very much now being forced into areas that are managed for other purposes than shorebird migration. So what happens then is that when there is little water in the mid-continent, and those agricultural areas are being tilled and planted for corn and other crops, very few wetlands actually exist for godwits, and they expend significant amounts of energy searching for those wetlands, and that seems to be minimizing their survival. So this graph right here, again, shows you on the y-axis the proportion of godwits in Alaska that are returning successfully, they're surviving their migration. And this time on the x-axis, we have the amount of precipitation that has fallen in the mid-continental US. So years with low precipitation there on the left have low adult survival for the godwits. And it's really a dramatic difference, actually, in the range of precipitation that we might see. So a 20% change in adult survival between dry years and wet years. And given that godwits are supposed to be long-lived birds, the fact that adults are actually the ones who seem to be getting hit hardest is really unfortunate for their population dynamics. So we see that over the past decade or so, godwit survival, adult survival, has declined. And we also see that the number of birds coming back to actually successfully breed in Beluga has declined over that same period as well. And if we then scale up to look at what's going on with the entire Alaskan non-breeding population on Chiloé, between 2014 and 2019, we see strong indications that godwits were declining there too at the sort of entire population level. So it wasn't just our the little study population we have in Beluga. This was seemingly across the entirety of their non-breeding range. So that's not a good sign. But I now want to switch gears a little bit and tell you some other stories about work going on in my lab that I think hint towards signs of resilience in shorebird populations. This is my PhD student, Julian Garcia Walter. He is from Northwest Mexico, and what he's doing is he has been leading a program to set up Modus towers just across the border from y'all and around the Baja California Peninsula and the Gulf of California. Each of those yellow dots that you see there is a Modus tower that they've erected. And what those Modus towers allow them to do, if you're not familiar with the program, is to actually track the movements of not just, say, the species that you might be studying, but a whole host of other species that other people might be studying. So it's really a collaborative approach to tracking birds. And what these Modus towers are allowing Julian to do is to understand how his particular study species, which is the red knot, is responding to sea level rise. And the story isn't quite yet positive. I can't sell you short. These are Julian's predictions for how much red knot habitat is going to be lost and the decrease in quality of the remaining habitat by 2050 for knots. So they're estimated to lose about 35% of their habitat, and the remaining habitat is supposed to decline by about 25%, all as a result of sea level rise. And you can see over here on the right-hand side of this graph, those red and green colors are the map of in 2050 where that habitat is actually going to be lost. But the signs of resilience are actually this. It doesn't look like much, but this is a floating mat of seaweed and seagrass and algae. And what it is it's providing a roosting habitat for thousands of shorebirds on these incredibly high tides that, in this case, only occur once every little while, but in the future are going to occur potentially on a daily basis, otherwise normally completely inundating the places that shorebirds would spend their roosting period. And so Hudsonian thinks that this is actually a really exciting find because, yes, in the short term, it's like, oh my goodness, there's no place for them to go. They're having to sit on these little mats that are floating around in the water. But these are exactly the kinds of things that we can potentially create ourselves and put in places where they might be used best. And what Hudsonian's been able to show with his tracking data is that red knots are actually able to find them, even though they move around from place to place each day with the currents, and they're able to make use of them to spend that high tide period. So what we have on the left here is tracking data showing the movements of a single individual red knot over the course of a number of days. And that blue line is what it did during one of these extreme high tides. And the numbers that you see correspond to this graph on the right, which is the actual tidal elevation, where the water is during its tide cycle. And so during this box that we have right there, numbers 8 through 12, it's spending down here in the lower left-hand corner, which is on one of those floating mats that Hudsonian has found. And so these knots, they're able to find these places, they're moving around from day to day. And we think that this is one of those maybe sort of glimmers of a way that we can start to work with the inevitability, given our current trajectory, the sea level rise and other factors of climate change, to potentially ease some of the issues that shorebirds are otherwise facing. I also think that there are real, genuine signs of hope that we ourselves can make change happen. For that, I'm actually going to switch to the Atlantic Flyway, and I'm going to introduce you to this little place. Watch that orange arrow and look at what is, if the video runs, what is starting to appear right near that orange arrow. This is a sandbar that did not exist in the early 1980s and has formed since then. It's now called DeVoe Bank. And a few years ago, a colleague of mine who's a biologist, was anchored off of DeVoe Bank early one morning because she was going to do some seabird surveys. There is a brown pelican colony out there. And what she witnessed was this. Tens of thousands of whimbrel taking off as dawn approached. This was not something that she'd ever witnessed despite working in the region for more than 20 years, and came as a complete shock to basically anyone she mentioned it to. Nobody thought there might be a place where tens of thousands of whimbrel would be spending any night, let alone night after night after night. And so that colleague is Felicia Sanders, who you see on the right here. She works for the South Carolina Department of Natural Resources. And along with Andy Johnson, a former student of mine who's a cinematographer at the Cornell Lab of Ornithology, and my PhD student, Mana Handmaker, they've put together a team that's been able to go out and document what has been going on DeVoe. And if they set up for nocturnal roosts during the spring migration period, during the month of May, and count the number of birds that are coming into the island by the moon, they found something truly phenomenal. And that is that this tiny 1 kilometer by half kilometer sandbar is currently hosting on a nightly basis more than half of the entire whimbrel population in eastern North America, more than 20,000 birds. Every time I look at this graph still, I'm just blown away. That is a crazy concentration of birds. And Felicia and Andy were able to use their media skills to get this story out into places as famous as the New York Times, but also little local media outlets, and to really do a full court press on the media. And what happened within a year of that full court press taking place, is that the state government in South Carolina closed the beaches on DeVoe Bank from human disturbance. They ceased what are called Coast Guard flyovers. I didn't know this, but apparently the Coast Guard flies the length of the US coast each and every night, and they're often flying at really low levels that scare up and disturb the birds. They've also then successfully been able to limit access to other South Carolina state-owned barrier islands, which are popular places for people to go and party and have their dogs running about. And then they've actually gotten the government to explicitly say that they will incorporate shorebirds and their well-being into state decision-making. So all of this, just because something was so incredible and I think so hopeful that people were galvanized to do something about it. So what we're now doing, and what Mayna's doing right here in this photo, is putting, of course, some tracking devices on these whimbrel to figure out where they go when they leave DeVoe each day. Because they do leave, they spread out, and what she's found is really remarkable. These dots are each individual whimbrel and showing their movements over the course of a couple of days. And if you follow them, right, they're spreading out over a humongous area along the South Carolina coast. Some birds, like this one in purple in the lower left, traveling more than 50 kilometers one direction each day in order to go and find a place to feed. So what we're then hoping to use this knowledge to be able to do is to actually place other potentially artificial DeVoe banks elsewhere, so that whimbrel may not be having to commute such long distances in order to find both a good place to forage and a good, safe place to spend the night. So this is DeVoe Bank from the air. You can see it's not necessarily that far off the coast. And if you noticed in that first picture, it's right next to one of the most popular resort islands in all of South Carolina. So we think that this is exactly the kind of thing that, again, working with folks like the U.S. Army Corps of Engineers, that we can figure out how to do in a hopefully man-made but purposefully placed way to make better habitat for birds. So that's the note of hope I want to leave you on. And then to bring it back to maybe what each of us can do, think about some sort of personal activities. Well, the first one is, from the story of Chihuahua, from the story of DeVoe, minimizing disturbance on beaches, especially during migratory periods. We know that even though more birds aren't necessarily dying directly because we might be out on the beach or letting our dog out on the beach, those the amount of energy that birds are expending because they've been scared up actually accumulates and has real repercussions later on down the line. We also know that we don't need to be confrontational, and so engaging in acts of science communication can really work. I also urge all of you to become a part of as many community scientist programs as possible, whether you're seeing banded birds out there and recording them to places like bandedbirds.org, which is where this screenshot comes from, or putting them on eBird. I actually, every now and then when I have time, comb through all the photos of Hudsonian Godwits to find pictures that people have taken of birds that I've put flags on in various places. And then the last one, because I know it's really contentious right now in California, maybe the hottest button issue, but water. We all can think about where water is and how much of it we're using. And also, in a good way, though, we found that if we can put it in the right place, shorebirds are able to make use of it. This photo comes from the Sacramento Valley, where the Bird Returns program, led by California Audubon and the Nature Conservancy, is really showcasing how farmers and the state and conservation organizations and community scientists can work together to get shorebird habitat created at just the right time. So, with all of that, just want to thank all of the awesome folks that are in my lab, the great team of collaborators that I've been able to work with, and of course, the funders who make all of this work possible. And thank you all for listening.
Thank you. If you mouse over your screen, there is an actual applause button on the left. We can do some virtual applause here. That was really great, Nathan. Thank you. So we've got the chat open. And
Let's see if I can view all of it.
yeah, and if you want to stop sharing, that'll make
There we go.
everybody more visible. So we'll take questions, comments, and you can just unmute and go ahead and jump in if you'd like to ask a question, or you can pop it in the chat and I'll read it. Or we do have a couple of people following along on Facebook. You can put it in the comments over on Facebook. I'll pick it up and get the question asked. There can't be no questions. That is not possible.
It's all right. Don't be shy, though.
Yeah. So have you, so here's a question about the technology.
Mm-hmm.
When you do the GPS trackers and they got light enough, is that dependent on you catching that same bird again, or do they broadcast and then eventually fall off?
It totally depends. So there's a whole gamut of technologies. The one that I showed you on the back of the bird, that is transmitting, and it actually has a little, so we get signals from it hopefully every day, and it actually is solar powered as well. So the battery's constantly recharging, and so for those we hope that it will last, not necessarily the entire life of the bird, but for multiple years in a row. So we've gotten up to 5 or 6 years of data out of them before they, the material just wears off and it falls off the bird. There are other devices as well. Some of the sort of the circle of the Hudsonian Godwit migration, that was coming from something called a geolocator that uses actually sunlight in order to just sort of give you a sense of where the bird is. And that we have to catch the bird again in order to take it back off. So depending on the question and the sort of the resolution of the information we want to get, we use a different kind of tracking device.
Great. Now here come the questions. From Kate, how do you coordinate with your collaborators in other countries?
Well, just like we're talking now, Zoom has been, or Skype before it, an amazing sort of facilitator of international collaborations. And we travel when we can, when it seems like the right thing to do, but a lot of it is just done like this.
Mm-hmm. And is the government of Argentina taking notice of the shorebird migration stopover areas?
Yes. So one of our collaborators works for the Argentine government, and they have developed a shorebird action plan just in the past couple of years. Now, as with any place, how much conservation gets weighed among all of the other issues that they're facing is an open question. But they are definitely aware and partners along with the government of Chile and the government of Peru. Even I didn't quite tie Peru in, but yeah, lots of work going on in South America with shorebirds.
Yeah. Next question comes in. What about marbled godwits?
Oh, they're so boring. They don't fly that far. Come on. Yeah, well, most of them, the vast majority are going to Baja California, to Guerrero Negro, actually, the place where the red knot work that I talked about is taking place. And, a lot of them are breeding in the prairie provinces. A very few are breeding on the Alaska Peninsula, which is the base of the Aleutian Islands. So, their migrations aren't quite as epic, and indications are that they're not doing as badly as Hudsonian Godwits are. But that said, they're not necessarily doing that great either. So not as quite a dire situation, but not doing so hot either.
Yeah, and I'm just going to add one of my own questions in here in the middle. Is your lab doing any work on the Atlantic migration of red knots? And if so, have you gotten into the question about the horseshoe crab take that was up recently? Because we actually got involved as Ellie Audubon and wrote a letter encouraging the regulatory body out there to not increase the allowable take of horseshoe crabs until there was actual increase in the populations, both of the horseshoe crabs and the red knot. So I'm curious if you've had the opportunity to work on that issue.
You know, we have just a little bit, mainly from the South Carolina perspective, and so we actually had some undergraduates who were working with Felicia Sanders, the colleague at South Carolina Department of Natural Resources I mentioned. And what they documented is actually the second most important stopover site for red knots on the Atlantic Flyway is in South Carolina, just on that resort island opposite of DeVoe Bank. So we estimate that there are about 20,000 red knots using that place, and that many of those birds actually don't stop in Delaware Bay. They fly from South Carolina up to the Canadian Arctic. So it seems to be sort of a separate set of birds that are using those two sites, but they're also dependent on horseshoe crabs. And so, yeah, we have had our own sort of back and forth with other parts of the South Carolina state government about horseshoe crab takes and where they're allowed to take them and how many. And there was a big push to increase that take this spring, and they ultimately decided not to. I like to think in at least some small part because of our work, but a lot of folks there really up in arms about horseshoe crab.
Great, thanks. From Gail, what is the status of habitat in the Yellow Sea?
Ooh, well, you know, maybe the message of the night is there's some good stuff and some bad stuff. You know, obviously we have seen really dramatic losses of habitat in the Yellow Sea, really dramatic declines in the shorebirds that use those habitats. But the Chinese government has, within the past few years, really come on board to try to reverse some of those declines. And then actually, international banking units have created recently this humongous, I'm going to forget, but I want to say it's $2 billion fund to look at wetland conservation in the East Asian Australasian Flyway, especially the Yellow Sea, to try to both benefit people and birds. So there is a lot of actually really good stuff afoot in the Yellow Sea. How well it's reversing what's already been lost remains to be seen. But at least, yeah, another note of tentative hope.
From Congo Red 16, what are the most immediate actions we need in Los Angeles to improve the habitat for migrating birds?
Yeah, you know, I think come back to some of those personal level actions, right? Disturbance, you know, urban environments are just often, well, they're urban, right? They have lots of people, they have lots of other things going on, and making sure that we can sort of try to identify ways to minimize that disturbance, or at least have it take place during periods of time when it's sort of not going to cause quite as much harm to shorebirds. And then water. I mean, you know, wetlands need frequently both fresh water and salt water, and so making sure that fresh water can still get into some of those places and, you know, create the habitats that shorebirds are needing, because not every shorebird, of course, is a sanderling that's just, you know, running around on the beach. Most of them are using either brackish or largely fresh water, at least for part of the day. So yeah, I would say those are really the two things: carving out sort of low disturbance habitats and making sure that there's actually water on the landscape.
Yeah, we're involved in, let's just say, discussions about that relative to one of our major wetlands here in Los Angeles, and the need to actually respect and protect the brackish freshwater components instead of converting it all to a deep full tidal, which isn't going to help the shorebirds at all. And we've done a lot of work on the historical ecology side of demonstrating how much of these upper wetland habitats that are predominantly freshwater driven and turn into salt pans in the summertime, how prevalent they were on the landscape and how much we've lost those. They're the sort of the thing that, in terms of coastal wetlands, we've lost those more than anything in, you know, from Ventura County to the Mexican border. And the other thing I would say, because this is, you've answered from the shorebird perspective, we've had some other talks about wintering birds, forest birds that come and winter in Los Angeles. And they're the important thing. So all of our warblers that show up. And the important thing there from Eric Wood's work, who of course recommended you to speak tonight, is the incredible importance of having the right trees. Even though in many places, Los Angeles is an artificial forest. There are places where it's a natural forest, but there are many places it's an artificial forest. But even where we're an artificial forest, we can serve an important role for wintering birds, migratory wintering birds, by planting native tree species. And if they're not native to LA, maybe native to California, if not California, to North America, if not North America, even the northern hemisphere makes a difference. And it all goes back to one of the slides that you had earlier about insect biomass, because the closer we are to the species being native to Southern California, the greater the number of species possible that are going to create that insect biomass, that these birds that migrate thousands of miles over land to winter or stop over in Los Angeles, the greater the amount of food that's there for them. So that's another place that we're paying a lot of attention to and advocating around. Actually, our newsletter that came out just today or yesterday, I wrote up a piece about how important the urban forest is for the birds, and it's the forest bird corresponding argument for the city for what you're talking about for shorebirds. So thanks for that question. Do we have any other questions? Anybody want? Well, wonderful. Well, thank you. This has been just incredibly enlightening. Really excellent presentation, and there were a few places there where I know I should have known these things, but I was just going, wow, that's really, really incredible ability that these species have, and the thought of losing them, and having evolved this over hundreds of thousands and millions of years, that it's now threatened in some instances with disappearance is really sobering. So thank you for your work on it, and thank you for joining us to talk to it about it tonight. So with that, I'll just end the broadcast here. Good night, everybody over on